Hello, I will present the work entitled Analyzing the Effect of Iron Addition into Ti-20Nb10Zr-Fe iron biomedical alloy fabricated by arc melting. The main purpose of this work is to analyze the iron effect on the stability of the beta phase of titanium and the consequence of the mechanical and corrosion properties to this addition. To prepare our samples, we use an induction melting furnace, and we weigh the materials in the stoichiometric radio to obtain different alloys compounds of titanium, 20 niobium, 10 zirconium, and we varied the iron from 1 to 5 atomic percent. The alloys were then metallographic prepared to observe the microstructure by scanning electron microscopy, and then the X-ray diffraction patterns were obtained to determine the crystallographic phases in the materials. After that, the samples were prepared for mechanical properties by nano, micro, and macro indentation. From nano indentation test, also the elastic recovery is estimated from the curves of charge and discharge. Finally, we run corrosion test under Ringer solution at 37 degrees to evaluate the behavior of such alloys under simulated fluid corporals. So the results shows that the addition of iron generates a stabilization of the beta T phase. As we can notice, from 4% of iron we obtain only the beta T phase. Lower this quantity of iron, we obtain a mix of phases that are composed by martensitic and beta T phase. We can notice that the needle-like shape observed in these 3 micrograph indicates or confirms the alpha prime phase, which is mainly composed of titanium, as we can notice from here. In the other hand, when we have 4 or 5% of iron, we obtain only a beta T phase. So we reach to the stabilization of beta T phase, and we notice that all the elements are homogeneously distributed. So the consequence in the mechanical properties are that from 4% and 5% of iron we obtain the highest values of hardness, no matter if we are measuring nano, micro, or macro indentation. So from that, we also notice that the elastic recovery increases as much as the iron quantity is added. So the largest elastic recovery is obtained for 5% of iron. This is really related to the beta stabilization, so we can say that the mechanical properties are better when we have only beta T phase. On the other hand, we present the Tafel curves for the corrosion results, and we notice also that a better behavior is noticed when we use highest quantities of iron. So the E curve is more positive as we increase the iron until 4%. Then when we have 5% we chose a small decrease. The values of E-core are close to those reported for similar alloys. We also noticed that the behavior shows some peaking for the 5% iron. However, the lowest corrosion rate was estimated for the sample with 5% of iron. After that, we conclude that the 5% of iron is the optimum quantity to be added to the alloy in order to get the better combination of properties for future biomedical application. Thank you.